Alright guys, welcome to yet another part of our Formatables Refactor, part 18 I believe. So we're gonna go to the next type. I mean, I guess these videos are becoming probably increasingly boring because we're doing more or less the same thing. I might skip a type or two, or perhaps we should just record everything to give the proper authentic experience what it is that we do. Now then, what we are trying to do at the moment is to get rid of these two types. The next one is going to be test data properties. I think this is fairly straightforward. So the text data properties lives at the element level. In fact, I look very carefully here. I don't. Oh, here we are. Attribute level test data properties. So it's property of the attribute. I wonder what this string is for. Let's have a quick RG. So what is RG? Let's make sure we are recording. We are. So don't seem to be doing very much with it, if I'm honest. We have it in the element properties, but that's very peculiar. Doesn't look like we're using it at the moment. I was convinced we were using this type. Well, as with everything, should always try to remove it and see what happens. Now I'm convinced that we are using this somewhere, but that's not what is not what my RG is telling me. So I'll have to test that. I'll have to trust. Sorry, I'll have to trust RG. My brain's still not quite functioning today. Bit of coffee, perhaps. See what this does. But this is exactly the kind of types we like. Something that got lost in the midst of time and never really use it. It will be very helpful if you have one or two of these. Sadly, we are pretty sure that the aspect properties are being used. So these, what we called aspect properties, really are technical space specific properties, which in a way are not too dissimilar from streaming properties. The only difference with the streaming properties, and the reason why we ended up doing what we did, is because the streaming properties, which are also technical space specific more or less, we really, well, we just didn't have the bandwidth to do the streaming properties properly. But I think what we're calling the aspects properties are easy enough. Oh, and there we are. It is actually clear. In Formatables model had really bit-rotten quite a bit. I mean, because we knew it was no longer just do this commit. So remove test data properties. Because we knew Formatables was no longer strategic, we just left it as it was really. And is really in dire need of a cleanup. Right. I wonder if we are still using the building, since we don't have any factories here. We probably don't need the building error anymore, I think. Let's have a look. I think tests. I'm pretty sure we still have a lot of expanders, so the expansion error is probably still in use. Interestingly enough, the test data properties expander, okay, that was green. Move building error. This clearly was some kind of experiment we were conducting that never got very far. Bit of luck. This will just be very straightforward. No, not even be plugged in. Clearly it's not plugged in to the main workflows and factories and so on. So I reckon that will just go through. And that was the factory, the expander. Let's get rid of that. And away we go. Okay, we had a couple of easy ones for a change. Now let's target the definitely non-trivial one. Right, for this guy, what we'll do for this guy is we will I'm not entirely sure. So that's just basically the workflow using that guy. Right, for this guy, what we'll do is we will see the aspect properties being used here, and there's a one-to-one mapping of element properties to aspect properties. So these are not specific to physical model. So now the question is, as you can see here, we're using this for every model type. However, I bet you that only certain specific types require these aspect properties. So what does the aspect properties expander, what does that tell us? I bet you that we are only doing this for one type of elements. No, we are doing it for every type of elements. No, there we are, bingo. Okay, so that already tells us what we need to know. So now then, let's go and look at our object. Anything in the object that is vaguely similar to aspect properties. I think I'm just gonna, this is clearly gonna be a hack, as you can expect, because really we should have technical space specific properties. Don't think there's anything vaguely remotely connected to this. So right, let's find some space then to add our new guy. I mean, you could even argue that we don't need to separate this from the object itself, and you would have a point. The only thing to keep in mind is to remember how these guys are being used. So we probably will have an element, won't we? So I don't think that's a problem. Okay, I'm actually gonna take that approach. Let's just say that's the visitor more suitable for this little gap here, perhaps. And think about this for a second. The module, a lot of space here, unfortunately. this is one of the things, one of the biggest annoyances of graphical modeling is that you end up faffing quite a fair bit. Just to get things in a shape that's vaguely reasonable. At least for an OCD person, it's almost the worst possible combination. Right, so I think it's vaguely reasonable to move this guy here, move the built-in here, which then gives us the space to move these two guys across. Now I'm not sure if we've got enough space to do what we want to do, so let's just steal a bit of space. And perhaps we, well, elements are already pretty pushed to the left there, so not a lot of space. Okay, so that wasn't completely the solution to our problems, but in fact the real solution may just be just need to find the right size here. Object clearly doesn't fit here. Or, of course, there's always a plan B, which is a screen going on downstairs for some reason. Okay, cool. Well, we'll go with that. Not perfect, but could be worse. And I'm actually going to be completely, incredibly lazy and just basically say, well, these are just object properties. Now, the right way to do this, of course, would be to say that there's technical space specific flags, and this could probably be an enumeration or something like that, I don't know. But we're not going to do that for now. Just going to get these guys here for a moment. Cool, so that's that, and then now let's look for a transform that could be good for this. Don't think we have anything suitable. If there was already some kind of object transform or something, but I don't think we do. Just have to create another one. Sadly, we already have a fairly congested sort of space here. But there you go. Let's just go for the left-hand side, I think. Now, I'm not entirely sure what's called this transform. I mean, I could call it technical space properties, or certainly can't be called aspect properties, given that this has nothing to do with aspects, I don't think. Yet another experiment we must have done in the past that didn't quite finish the way we'd expect. One thing we did not do is to check the volume. We've been having a lot of problems with sound of late. Hopefully the sound is going to come out alright. Did not copy that model, but so now what should we call this transform, I wonder? Could be what are these? What's in common with all these properties? I mean, I should really call it technical space specific properties transform. That's a terrible name. Something like that. But well, something like this. Because of course, when we what we really want, I mean, you already have the technical space transform, a bit overloaded. We should need to make sure that the names of the transforms are vaguely clear enough that we remember what they mean when we look at them. That we'll have to do for now. The other thing we need to do as well is we need some features, because these guys are all read from config, so I think we just need something like this. And we should probably call it technical space properties. And we need some color for it. Probably the bad. There we go. And now we'll just do a couple of things. First is we will, well, for now we'll keep this little convention of aspect, though we definitely don't want to call these aspects. Now it's a bit of background for those that are interested in this kind of stuff. So there is aspect-oriented programming, and we are using some techniques from aspect-oriented programming. For instance, that which we call helpers at present are roughly aspects. However, we are trying to get rid of that approach because the approach has caused problems more than anything else, really. The aspects that we have, if you really want to create a proper aspect-oriented approach, you really need the infrastructure for it, and it's not clear at the moment that we really need it. It's more that the reason why we have helpers in the first place, in fact, is because we thought it would be possible to generate a model without having any dependencies whatsoever. Well, with very limited number of dependencies, should I say. And I'm not entirely sure, maybe we should just flip things around here a little bit. And the idea being that it would be nice if you didn't have to include a third-party model in order to generate the model. So as an example, let's say for instance you're trying to generate a vector, and the vector needs I/O, needs to be dumped to a stream, for example. At present, we use a helper that knows about vectors and it knows about dumping them to streams, and that helper just gets code generated time and time again for each of the use cases, each of the cases where we use the vector. And there are advantages to that approach because we now don't have a dependency in a very small file that provides us with that method. But there are disadvantages as well, because now we have the same code duplicated all over the place, which then causes the compilation times to go up. And so our general conclusion was that actually there is such a thing as a platform definition model, and a platform is just basically anything that's external to Dogen, really. And because there is a platform definition model, one has to then ask, well, if we need a platform definition model, shouldn't things like the extensions think of the outputs as an adapter that makes the whatever type fit? So the question to ask then is, well, if that's the case, why not simply just make sure that the platform definition model contains the types definition as well as any adaptation that may be required, which is obviously the right thing to do. And that's the approach we're going to be taking in the future, which I think was going to be a much better approach. You just basically you create the adapters in one place, do the change once, and that's it. Okay, so I think a bit of noise downstairs. Hopefully it's not causing problems. Okay, I think we may have made no, that looks good. What did we do? We did something very wrong. Not clear. Sorry, wrong window. Right, so what do we do then? A MASD.variability boolean. Now I think MASD variability boolean is clearly a valid type, so I can't see why that would be a problem. No obvious typos. Quite puzzled with this actually. Okay, let's just concentrate for a second. Must be doing something very, very silly. Can't quite see what though. Just make sure we didn't change anything else by mistake. This is where the JSON model tends to be helpful, because we can just see what we changed. So we removed all these guys. That looks perfectly reasonable. And then we added... okay, right, so this is just the type we added. And... perhaps we forgot to... yes. Okay, so we really need to improve our errors. We just forgot to put the stereotype here, which then means that the mapping doesn't take place. So we probably really should have said there a nicer error. Not quite sure what we should do in those cases, but let's just keep going. So let's convert logical model. Right, now this will work, and it's going to regenerate a whole lot of stuff. And if we then run all tests, hopefully make sure we're still in debug, in release, not debug. Yeah, we are. Right, so hopefully all this is going to do is going to create a whole lot of properties that we added to the logical model. It's going to create features for these guys here, and it's going to move the features that existed here. Nothing should break, it should all just work. And once that's done, we should just, well, that's going on. Should have a very trivial transform. It's just this guy here. And all it does is, I think we made a mistake here. What do we? Oh, okay, we definitely made a mistake here. We didn't read carefully enough. We are also changing the primitives. Now, sadly, this is not good. We are also changing the primitives. Presumably, what should we do? Right, I'm gonna go for the midpoint and just okay. Right, so first we've already done this change and the tests are passing. So let's just go for logical first stab at modeling aspect properties. Right, it's not our last stab, sadly. So what we're gonna do instead is let's just create an object template here. This is what I mean about concentration. Really, it's hard to do these things properly. So technical space properties, and I'm not sure what the color is for these guys. E3B. Right, so what we'll do then is we will just create a little template here. And our template will have these three guys. And the pool. So with this little template, we can now say that these guys have the template. This guy is clearly becoming a little bit out of control, as you can see by the amount of templates we're using here, but there we are. This is a very large number of templates there. And with these, well, sadly we're going to have to go through the whole conversion, indentation, generation. Right, now both the object and the primitives will have them. Seems like it moved around a little bit, not a big deal. Don't think this will cause any problems. Right, so now we've added these properties to both the primitive and the technical and the object, should I say. Again, we have a long compile here. Hopefully we haven't missed anything obvious. And what we can do now is we can see, in this particular case we won't be able to do the clever things like we did with the lambdas a second ago. We need to loop through all the types when we need to find the right types. So I think we will need a visitor. I mean, we know for sure what these guys are, so there's no point of looping through the entire model. So we just loop through. In fact, to be honest, we don't even need to do that because, of course, we have containers for primitives and containers for objects. So we just loop through one, loop through the other, and create a template method, presumably, that will copy these guys across. And that is it. However, there's a level of walking the name tree here. Okay, we just have to be very careful here because we are walking the name tree looking for... What are we looking for? I think we must have already... I mean, what is an element AP? One wonders. Require stream manipulators, so... slightly confused here. Oh, it's one of us, yeah, okay. So what we're doing is... we are looking... we must have a container of some kind. And... yeah, okay, fine. So clearly what's happening here is some magic is going on. Yeah, so we created a container of these properties, and then we are resolving... this is a two-step process really, and then we are resolving based on what attributes these different guys have, we are resolving their settings. Of course we don't have such a container right now, so it's not ideal. I have been trying very hard to create a type for this class, but it's more and more becoming obvious that that's not going to work. Oh well, not much I can do really. So let's call this our second stab. Now it's not going to work because we need to follow through with that approach really. We need a container that contains these guys because we then need to loop through and resolve the properties and the attributes into them. So there's really nothing we can do, as much as we may try to avoid this. Right, okay, third time lucky, hopefully. So what we're going to do is we're going to change this guy here. We're going to stick with having a template. I'm just going to move a few things across. So let's say that this guy here is still the template. But now it's going to be a slightly different template. It's going to contain now I can't quite remember what the right color is. Oops, it chose a very bad color there. F7E. So if I just go to an F7E for this guy, and then if I say actually just a plain object, and you contain, well, I'm actually going to give up and just call this technical space properties. That's about it. And now what we're going to do is we're going to basically say, well, the template just has the properties. Sometimes you're lost for words in terms of names. And that is it. So now then, just lower these guys a little bit. And let's just say that this guy here contains, oops. Dia sometimes is a bit puzzling. I don't know how it determines the shape of the connections. Right, so there we are. So as you can see here, the technical space properties now are, well, there are many things. There are templates that applies to both the primitive and to the object. There are also a little class with those type, with those little, basically bundle of things. And then what we're going to do is, in the transform, we'll follow exactly the same approach. Two-pass sort of approach, obtain the properties, record them in a container, and then use that container to resolve whatever it is that we got in the attributes. But presumably what that will do then is just this what's happening here is we're trying to figure out whether we need to propagate some properties, I think. So I think we'll be alright actually. I wonder if I should lower this. Right, okay, third time lucky hopefully. Indent, no, convert, sorry. Indent. Get rid of that. Generate. And as you can see here, if this was work, I probably would not bother keeping all the different versions of things. But I do like doing this so to record whatever it is that we try. I think it's a good thing. The history is really there to help you, right? And sometimes it's good to be able to go back to different versions. Like say for example in 5 minutes we conclude this is the wrong approach, you want to remember what we did. You can just check out that commit. Have a look at the model and so on. And many times I've used this. So I always record every all the failed attempts. I find that quite useful actually. So there we are. Something else will be data driven at some point. Pretty much all the enumerations that we got at the moment are just hard coding. They need to be data driven. So where are we then? We do have a new transform, and we know what that new transform should look like. We don't need to do any of these, make this, make that, but approach will be similar to the string properties. Right, this guy here will be responsible for all the reading. So we will need some kind of class to we don't need to visit as such, but it will be nice to have some state so that it just builds up that container. Oh, it looks like our compilation is finished, so let's just That's now taking quite a long time now. Slightly less optimal. Okay, so final stab at modeling aspect properties. Right, cool. So I'm just gonna go with these ones now, and what we'll do is, before anything else, let's just get technical space transform, and we will just use some other transforms such as the streaming properties transform as our baseline. Not sure we need the optional here, probably in the CPP I should think. So we'll probably need something like a context in a model, I should think. And that we do. And then we just apply. Right, very, very simple. And if LSP would allow us, reads technical. Not sure why the LSP is so unresponsive at the moment. So we are trying to read this technical space specific properties with this guy, and what we'll do as usual, we will just create the skeleton of the transform, we'll hook it in. It's probably a bit boring stuff. I think I've made something. Too many copy and paste. Let's go for this approach. Right, so what we need to do then is we just need the usual throw exception, probably a bit of a logger, a bit of a tracer. We'll need some model IO. And probably need the configuration selected too, given we're going to copy the approach. So this guy here will just not sure if we need the big. Oh, actually, I think we will. And there we go. So for this now, we just need to make sure that we trace like a good transform should, and update this guy. Okay, oh, trigger happy there. And then we just need to choose a nice little place for this to be hooked in. Now I think there is no dependencies whatsoever for this transform, so I just go to the pre-assembly chain. I can just choose any lovely place to put this guy in. Don't think it really matters. I think we already have a whole bunch of transforms. Yeah. These are sort of not too problematic, these transforms. This should really do nothing. Just a skeleton for the transform. One thing we should really do, actually, while we're here, is to have a look at what other aspect properties we have. Right, here we are. So let's just not waste time and do C# and C++ in one go. So is floating point, do we also need that? No. So what we're going to do is, to save us time, let's just tackle 2 in 1. Or actually, no, do you know what? let's just do one at a time. The reason why I say that is because we're going to have to add the features, we're going to have to do a whole lot of things here. So what we'll do is, let's just do C++ first, then we do C#. Let's just went through as expected. So let's just add skeleton for technical space properties. I actually don't know how to use the numbers. Alt. There we are. Oh, okay, that's really useful. So company seems to use the alts and the numbers. Okie doke. So now then, the first thing we need to do is to figure out. No, we are in streaming properties. Okay, I think what we're going to need from streaming properties, we already have the configuration selected. We're going to need some features as well. So I'm just going to take these features here. I'm pretty sure, well, God knows what we call the features, so we will just grab them. All of them got the same name. Clearly we can see that there's some fatigue naming things at the moment. So in here, the aspect expander, there is a type which contains the properties. So all we're going to do is we're going to create one of those lovely classes. This time we remember the namespace. I really don't know what to call these sort of classes, but you know, they seem to gather things. I really mean to say private here, clearly. And I think we need wherever this thing is going to be, somewhere like types, entities, structural. Oh, right, good. And then we could clearly just say this guy will make a little collection of these guys. Now we can't really do many usings here because we decided to use the same name for everything. So there we are. So this guy's job is going to be to go around and gather the technical space properties across different types of Now, if we look for how they are gathered, presumably the first step is to create them. Okay, so I wonder if we are, well, we need to gather, but, no, actually I think I got this all wrong. Yet again we are struggling a bit to concentrate. So we need to look through all the objects, and we need to look through all the primitives. We need to come up with the technical space properties for those, and then we just need to remember against the logical ID those technical space properties. Then we need to walk the name tree. That's probably only for the objects. I bet you I was to look at this guy here. Well, but to be fair, we are doing it for the primitives as well, but primitives will only have one single thing on their property and their attribute, so it's not a big thing really. Slight downside of this, of course, is we need to have a complete model, because yeah, so we made a mistake. We made several mistakes here actually. This is not going to work as it is, because we need a complete model, because we need all of the types to already be there. So there is a dependency in this guy, and if I just grab this guy, this has to go down to the bottom of our pipeline. somewhere like here. I should think. Reason being that we need to have every single type already in the model, because we will be reading properties from, say, for example, a stood string that's God knows where, and we need to have it merged, and we need to have all these different things there. So before we do anything else, none of this will compile. So I think this gather business is not going to be necessary. So let's get rid of all that. Let's go back to that pre-assembly, and let's open the post-assembly, and what we'll do is we'll literally just move this guy over to here. Now I'm sure we don't have to do this last, but there you go. I wonder if the properties. Well, actually, to be honest, it could be done at any point. Let's see if there's any place where we're doing a whole load of random. Okay. Properties don't have any particular dependencies other than the pin. Not sure why it keeps errors as well. Other than the model must be merged. Right. Now then, clearly, yet again, we don't expect any trouble. There you are. So hopefully this makes a bit more sense, right? What we're trying to say is that we can't really compute something global if we don't really have a global model. So let's just say move to post assembly. Right, so it's post assembly now, it's all good, it will be fine, and then we can now go back to what we're trying to do, which was look at the streaming properties transform. Right, so what we're trying to do here was, we're trying to say, in fact I will remember the gatherer because I need this guy here. We need to say something like, go through every type, primitive and object, compute their streaming properties transform. Well, no, read their streaming properties transform, and then we need to compute them. When we read the streaming properties transform, we seem to store them in a temporary container, and then there's a lot of noise going. Okay, now then, what are we trying to do? Actually, now we should really probably looking at the aspect expander. Yeah, so as we expected, the two-step process is first compute that. We're just going to compute it slightly differently, but similarly. All this is doing is loop through the model, make the properties, and so forth. So I think we can probably follow the same pattern. We're not going to do it exactly the same way, but we follow the same pattern. So what we'll say is, I'm not going to bother with the type def. Actually, we're not using type def so much these days. Take this guy. See what we're doing here. We are going to take this guy. We already had that container. I don't know why we got the wrong version of it, but there we are. And here we're just going to say obtain, and we need a feature model, and we will need the model. So this is going to require a feature model, a logical model, and the whole thing is static. Right, so this should hopefully be fairly straightforward to implement. So all we're going to do here, sounds complicated, but it's not. All we're going to do is perhaps something like this. We'll say something like for const auto reference pair m dot structural objects. Right, and this will give us our loop, which is equivalent to this guy here. We probably will copy the logic here. And then if we say something like not going to bother, should we bother or not with a method for this, because presumably it will be fairly straightforward, I think. Although having said that, we do have to do some silly logic around it, like that guy, to determine whether it should exist or not. I think it's simple enough. Although having said that, the other thing as well is we probably want the feature group to have been created by then. Right, so in this case we will just do something like, let's see, implement it first and see if we needed a method for this. So, not quite what we wanted. We wanted the features actually. So let's say I do something like this. Make feature group, and then if I say that on FM, and this will be something like auto feature group. Very simple. So there we are. We created the feature group. Then let's say that I go to each of these elements. To reference E there. Second dereferenced. Now what we need to do is we just need to look at the string properties, and we're going to do something very similar to this. Now we don't have to worry, well, I don't know if we're going to need that optional or not, but so we obtain the configuration, we go to the configuration, and then what we do is we, for our feature group, we look at the three guys, right, so if any of these, if none of these are available, then continue presumably. No properties were found. We can just say continue. You can see why we are in a minute going to end up having to create a method for this, but there you are. Right, there we are. So if none of the properties are available, there's no point to continuing. There's no point of well, continuing. Haha. So continue. We go to the next element of the loop. Let's get ourselves something like an object and a primitive. Right, there we are. So objects and primitives. Oh, I think we forgot to put structural here. Right, now then. So don't bother. Otherwise, create the properties and slot it into the computer. To be honest, even these comments are identical, so it's very bad form probably, but we're going to copy and paste the comments because we are saying the same thing. So we're going to create one of these guys here, and then we will create a static configuration and then just populate the guys. So getting a bit big here, but not a lot of options because everything's got the same name, so rather annoyingly. Right, so then all we need to do is quite boringly, that's a word, a lot of copying and pasting. You can see there's a clear pattern here between the streaming operators and these guys, but there you are. I'm not sure what we're calling this R, but there we are. Right, so this guy is basically copying the properties over to the TSP. And this is just TSP. So you see we've done something very simple. We just copy the properties across. Now all we need to do is to insert that into the container, which we probably haven't created just yet. So there is an R. And then see, it's almost identical to what we're doing here really, and then we just need to then say this stuff, quite literally. We have an ID already. We are going to be inserting ID against the TSP. The container is called R. I think I just went a little bit overboard there. And we need a transform. Not entirely sure why pair is giving us trouble. Ah, I know why. It's because we already had a pair. It's the easiest thing to do here. Be lazy. Okay, cool. So there we are. Configuration should probably be dereferenced. Okay, so we looped through every single object. We constructed the new version of the aspect properties, technical space properties. We slotted into the container, we returned it. I suspect the aspect expander will be almost identical. Just going to call these the TSPs. And we can do the usual so this is just a feature model, this is just a model, and this is this guy here. So very, very simple. Gone through the whole model. Not entirely sure why FM. So it just read all of these things on configuration from each type. Now the only question to be asked here is, when you're obtaining the aspect properties, did we bother to go to other types other than uh, objects? See, we don't really make a distinction. This is interesting, really. We did not make a distinction. Now this is really quite important, I think, because the problem will be, like, say you got something like an int, which is possibly a primitive, possibly not clear. Yeah, I suspect we are probably doing the wrong thing here. Let's actually not take, because I mean, remember, we are looping through the whole of Formatables, so that's every single element. So now we just suddenly transform that to something that's not equivalent. We're only looping through objects. There's many other types of objects. We could use the old trick of the lambda. I actually think this is probably the wisest thing to do. Let's just do a reversal here, because I'm afraid, I mean, even if this works for now, it probably will break in the future once we start moving things around. So let's just do it properly. So really what we want is a function that takes any type so this takes any type element and then reads the string properties, returns the pair, and then we slot that in. So we could just create another obtain aspect properties that takes the you're going to probably notice that this function is going to be very similar to something we've done already, hopefully. So this guy is going to go and take not the whole feature model, as you may think, but the feature group. So that we don't have to recompute the feature group. And of course it's not the streaming feature group, because we want whatever the features we have here. So this is probably better. Right, so now this feature group will enable us to read the dynamic configuration from any object. Oh, actually one thing we should do here as well is, we're not reading a model, we are processing an element. So instead of a model, that becomes an element, as you can see. And that then enables us to write something like this. Which will be most of the stuff we have here. Except, and of course we have to remember, now you can see why I said that sooner or later we're going to end up with a boost optional, because of course we may not have any properties, and if we just had follow the pattern we would have been alright, but we tried to be clever, and of course it just made us go around in a circle. Right, so now then, let's imagine we do something like this. Obtain the ID, e.name.id, process the elements. We don't need this anymore. We obtain the configuration, we read what we need to read. No properties were found. We just return whatever it is. if properties were found, we create the actual type. It's probably worthwhile seeing if we can make these things fit. We can't. Right, and then we just need to return. Right, so this guy will then do the hard work of reading the properties, and then the lambda will be almost identical. So we will just create this thing that we need to return. We start off with a feature model, and we will obtain the features. So we obtain the features, we create the container, the thing that we want to do, then we have our loop, and then in our loop what we'll call is, we'll call our overloaded method, which hopefully will be just the right interface, and then we will slot it into our lovely container, and for a good measure we will output this guy, and there we are. Very simple. Now presumably we'll have some problems with I/O. There we are. So as you can see here, this is very simple. All it does is it goes through every single model element now instead of just objects, and it will obtain these what we call aspect properties that really are not aspect properties, but obtain properties, I think. Right, so not too bad. Okay, so this should hopefully not break the world. All this is doing is reading the properties, and it did break the world. We forgot to output the logical ID. Authentication goes at the top. Right, so a bit of luck. Oh, good lord. I think our problem is that we are using a container of some kind. I think we're probably outputting the container. So this might take us a couple of goes. Right, so compilation has gone okay. Now we're going to see what the tests do. In theory, this should not break anything. All we're doing is creating the container. I'm not going to bother to commit this just yet, but it's all good. And now we can move away from the streaming properties transform back to the expander. So we've got as far as obtaining all the properties. Now we need to add the second part of the transform, which is the population. So obtain properties, populate properties, I guess. You can see that these names are getting weaker as we go along. We're gonna need pretty much, well, none of these guys, but pretty much all of these guys, I think. Not quite sure why we have a populate in the compute. Names are very dodgy, but alright, it's just that one of the guys loops, the other guy resolves over to a type, other guy. In fact, I'm going blind here, but I can't see any compute. There we are. Well, okay, do you know what we're going to do is, in the spirit of laziness, I'm just going to copy these guys across as is. We're going to slightly name them, rename them. So, for example, we will call this guy whatever it needs to be called, TSPs, and we will call this guy maybe just properties. Well, actually TSP, I guess, because it's the one, right? That's the complete container that has everything. And then we could just go to ID. So that will be something like types, not quite, types entity, logical name tree really. Yeah. So that solved that problem. So we supply a name tree of some kind, we supply all the states, we supply that guy. This guy is going to compute TSPs. Again, it's going to have something like this. I'm not sure why that is a pointer. And the attributes, and let's also include the list for good measure. Okay. Something didn't quite go well when we copied this guy across, actually. We forgot the map. Right, so const stood unordered map of the technical space properties. Oh, but it's clearly a map of what? Logical ID. Okay, then a series of attributes. Now let's just make sure this time we copy this. What is logical ID doing here? Not sure. Compute aspect properties. Yes, this is what I mean by concentration. You can see that we're making a number of very trivial errors while trying to do this work. If we were actually not talking while doing the work, this would be quite easy. It's very difficult to do it whilst talking, I think. We don't want any formatables here. Right, now then. Good God almighty, we still have some more. And the logical ID, and then the elements. I'm convinced that we don't really need something as complicated as this, but there you are. Oh, something happened here. Actually, I wonder if we have insert on or something. Let's look at this more carefully then. That looks correct. Ah, I see. The problem is we had a container of formatables that we're supplying. Right, okay, cool. This is going to be interesting, I think. Right, first let's just get rid of the aspects bit. Right, so the problem I think we're going to have here, I'm just going to use the model, I think. Now, we will have a lot of problems implementing this, because we changed quite dramatically the layout of the function. So what we shall do is just do one of these guys at a time, very slowly, so that our very low levels of concentration don't cause even more problems. Right, so hopefully it's all making sense so far. Now then, what we're going to do then is we're going to basically say now is let's just look at these methods one at a time. So the very first method, what does it do? It loops through all of the formatables and then calls something on it. Okay, so now if you remember, we don't have all of the formatables, we just have a model, and the model is not a linear thing, but what we do know is we know that we only need objects and we need primitives. So what we can quite cleverly do is we can say, actually, let's do 2 loops here. And the first loop will be m.structural objects. No, I just want the objects. And then, in fact, to be honest, if we just struggling quite a bit at the moment to just type for some reason. So first we go through our objects, and then what we do, we basically say, well, now I wonder why we need the logical ID. Right, so this is where we want to be very careful and try to understand what these methods do. Notice that we're asking for the element ID and then the aspects property type, which is the container. But then we're supplying the element itself. Now this sounds very strange. For processing the element, if we already got everything in there, why are we supplying the element ID? Not like that. So let's remove the element ID. Doesn't make a lot of sense to me. Can't really trust a lot of this code because it's quite old. So next we'd say, well, we seem to need the TSPs, and we seem to need an element. So if I just say auto by reference e pair.seconds, dereferenced e. Right, so that should get us there now, I think. And then the equivalent for primitives, because of course we call this e, now I have to call this p, and there we are. Okay, so this is now roughly equivalent to what the other guy is doing. And now we are supplying 2 elements to that guy. And then, so that's this guy done. Now the next guy is this guy. It's going to require a little bit of cleverness. The first thing is, notice that we need to cast from an element to the actual element, object or primitive. So I think we just need to understand a bit better what's going on here. Why must we cast? Well, first let's just start typing this guy and see how far we get. So processing elements, so const auto ID is e dot name dot ID. So we just say something like that. And then what we're saying is, what we're trying to do is populate the element properties. Those are going to be something like e dot technical space something or other. Oh, only primitives in objects, right? Okay, cool. Yes, get it. So starters, it's interesting to notice that we don't even need to bother with all of the types. So let's do that here. Right, so the provenance is at the model level. Not quite sure why that's called MS, but I think, if I'm not wrong, this should be valid. If I'm not wrong. Right, so presumably this will be equivalent, so we don't really need to worry about the provenance here anymore. See what we can make of this comment. We only need to generate the properties with elements of target model. However, we can't perform after this reduction because the aspect configuration must be built prior to reduction, or else we will not get to the aspects for reference models. Well, I should think that the rest of this comment is no longer applicable. Okay, something like this. I mean, we'll just fix that comment in a second. The key thing that seems to be happening here is that for each type of element, our objective is to obtain the list of attributes. Okay, cool. I think I get it now. So we are just trying to obtain the list of attributes, right? So I think we're going to skip one of these methods. This guy here is not doing nothing particularly special. He's just basically trying to figure out what to do to obtain the attributes. So I think really we can just skip that and do something like this. So e dot local attributes, compute that, supply this to the TSPs and the attributes, and this will give us the TSP. And then finally, what we're going to be doing is to say something like e dot technical space properties is the TSP, which means we could probably just get rid of these guys and say that's it. So that's a lot simpler, I think. And then we could probably say something like this, and something like this. Hopefully this makes a bit more sense. Now of course for primitives, handling is slightly different. Not overly different to be fair, but so we start with our P, we use the attribute to create a list of the attribute, we put that in a list, we obtain the TSP against the TSPs, and again same thing. We just simply slot it in. Right, now I think this is dramatically simpler. This seems to be doing the job now, I think. Which means this guy is no longer required at all. And that would have been this guy, if I'm right. Okay, now then, we move to computing the properties. Now, I think this function will be required because we're doing some kind of recursion here. There's no getting away from that, so we will need this little tiny function. It will take the TSPs, do whatever it is that it does, and I think that should have been it. However, it's not for some reason. Not quite sure why we're having a problem here. We'll ignore that for a second. Now let's walk the name tree. Right, so to walk the name tree, I think largely we just need a few renames here. And TSP. Okay. So go to TSP, find it, locate it, then the TSP, the thing that we're populating. We have to be careful here what we're saying. I mean, the names are becoming more and more awful as we go along, as you can imagine. Really, this is the thing we found on the TSP's container. We are really running out of good names here. Let's just try to get this thing to work first, and then we can clean things up. Right. Right, and then we would have thought all of these guys would have a const. Where am I? Const container. Right, okay. This is just to try to get us in the right place, and then finally we can just say populate properties, TSPs, and the M. Very simple. Job done. I forgot to make some of these functions static. Don't really need state, so it can all be static. Right, okay then. So now we are more or less done with the implementation. Took us an hour and 20. Okay, let's try to see. Randomly putting things like const everywhere. Okay, right, so probably what we've done is in our rush to make things static we forgot to take away the consts. Yet again it's a bit warm here. See how our build's doing from lunchtime. Travis is done. So what we were doing, we were just taking away the consts. Right, okay, so what are the errors left then? So, for whatever reason, we still don't seem to have the right complete properties. Entirely unclear to me. Right, this is where concentration is required. So this takes two parameters, first of which is const, second is const2. Can't see large differences here. Return type looks okay. Const, and then this is const, it's static. Can't really see any problems. Do we do a constant return? No. Right, sometimes it's better to just get the compiler to tell us what is wrong. Compiler is quite verbose, so tends to give us a little bit more of a fighting chance. Right, so there's a problem with the type of the first parameter. I bet you we just forgot to put a by reference somewhere. No, it looks alright to me. Well, when it gets to this sort of level where we just can't see anything, sometimes copy and paste is the best thing to do. Now, I definitely can't see anything wrong with the first parameter, so hopefully. Okay, and now populate properties. Similarly, we seem to have a problem with populate properties. Now, what is the problem? I'm not entirely sure, but these things look rather identical to me. Rather identical. So, but someone is returning the wrong type somewhere. Ah, wait. I can see already that there's a const that wasn't there a second ago. Ah, okay, right. I'm not entirely sure what's going on here, but clearly we seem to be adding consts fairly randomly. Right, let's just take another look at this. Right, okay, bit less random now. So, what are we doing then? We need some kind of names that make a bit more sense here. So let's call this original, because this is the original. Right. This is as it was read from the configuration originally. And, I mean, it's not the best of names, right? But it's slightly less bad. And then, so this TSPs is the collection that we got with all the original data. Which makes me think that we probably should call these things original TSPs. Yeah, okay, so let's then say these become the original TSPs. This is the well, actually we can call these the source TSPs and we can call these the destination TSPs, because that's what we're trying to do. We start off with the source TSPs and we're trying to obtain the computed values, right? So the source TSPs with the attributes, and these become source TSPs, right? And populate properties. We get the source TSPs here. We take those, we shove it in there, and in there. And we will, for good measure, also call these guys here the source TSPs. That's how we started. Slightly better name, not the best, but similarly, when we're computing the properties, we are taking the source TSPs, we are passing that up, and finally, as we are recursing, we take the source TSPs, we take the destination TSP, we keep supplying these to the recursion, and here we compute the destination TSP, go to the source TSPs to find, and now of course this becomes the source TSP, which is a much better name, and we populate the destination TSP. And now of course you could say, why don't we just always populate it? I can't quite remember why we're doing these ifs. Don't ask, we're just going to stick to this approach for now. You could just update the boolean regardless, really. There is some logic to this. Let's just not start hacking too much with that, because I think there is some logic to that madness. I can't quite remember exactly how this works, but that's refactoring too far for this stage. And believe it or not, we are almost an hour and 40 minutes into it, just to remove a fairly simple type. And we still have C# to do. I wonder if C# is not a different video. Perhaps it might be more sensible. Okay, cool. There we are. Green. So let's just commit this. Let's just call this implement transform. Let's get a code generator that's up to date. And let's code generate, make sure we didn't break anything. Right, cool. Okay, so now then, this new transform should roughly be equivalent to the previous transform. And what we need to do then is we need to think how to replace the existing stuff. So we already have an element. What we need to do is really to have a look at what the assistant is doing. It doesn't seem to mention the word aspects. Waiting for time. A lot of messages coming through at the moment. I'll check that in a minute. Right, there we are. See what's happening here. We are going to the element properties, obtaining the aspect properties, and doing whatever it is that we do. Now you will remember though that we don't really know what is the element, so there's no casting. So as you can see, we don't really know if this was say a primitive or not. So I think what I'd like to know is, this is something we've been avoiding so far, but question one has to ask here is this: can we not just rely on the element itself? Must we have this in the assistant? The assistant here is doing all sorts of cleverness, clearly. So this is where, yeah, sadly we can't really we could almost if there wasn't this level of cleverness going on here. Right, and to be fair, I think you're going to find that almost in every case is to do with the standard. So let's just remove that level of cleverness actually. So requires manual default constructor. So I think what we need to do here is we need to determine what the standard is, and if the standard is 98, we should always require manual default constructor. So perhaps and this is probably being done for well, whatever it is being done for, doesn't really matter, we don't care. So let's just remove this cleverness from the assistant. You can see what I meant by the assistant shouldn't really be doing clever things. It makes no sense for us to be so low level now and now to start determining these sort of conditions. It should really be done well before we got to the point where we're creating text templates and writing things to file. This was just a modeling error. So, however, now we need to figure out how to slot this into this fairly complex logic. We could probably start off by saying so if the standard is 98, we should always create a manual default constructor. Now, I am tempted to just go here and say, if the standard is whatever, just do that. I mean, here we just read stuff directly from the configuration, so it's not really nice to do that, because then it becomes a bit dirty. But when we're doing the walk, it seems a bit annoying to have to go through every single name tree, only to just say, well, if the standard was true. But we're not here to do the best refactoring in the world, we're here to just do something that vaguely works. So let's just keep track of that. So what we need to do is we need to say are we standard 98, and if we are, we should just so this is going to be something like model.technical space version, and then this will be something like const bool there you go. And then we could just do something like not sure why. Righty, so you see what we're trying to do here, hopefully. Pushing up the stack these decisions. And now we basically, let's have a look. So populate properties. Well, that has a model. Now I'm going to push this up a little bit, because if that's already got a model, then it makes sense for it to compute itself. And then the computation and the walk can then have the standard. I'm not sure where to put it, if I'm honest, but oh well, you know what, let's just put it at the top, because why not? Right, so hopefully this will be making some sense. Not sure if it does, but hopefully it will. Right, so now then, you can see we're just drilling through the layers. I'm not quite sure what we're trying to do there. So then, let's say that we do the walk like so. So we do the walk like so, and then all we need to do then is to say something like, well, let's just see what the system says. The system says something like, manual default constructor. So for the manual default construct, let's just see how much of the standard are we using here. Final keyword text we don't care about. Override keyword text, accept, standard itself, defaulted functions. I don't think we should probably have this as a property as well. Let's put a note here. Create a technical space specific property for defaulted functions. In assistant we have source C++ and source. This should really be in whatever is that we call these new silly properties, technical space properties. Make sure that there is no urgent messages coming through. Apologies, we replied to a couple of these things. Nothing urgent happening. So we're doing for time. Almost 2 hours. Okay, cool. So that clearly doesn't look right. We'll return to that in a minute. But what is more important really is the require manual default constructor. So if the source TXP requires manual or, so we can easily say here, if what we really mean is there is a very useful thing in Emacs called ACE mode, and I really should look into it a bit more. We don't really use it very much, but it's very useful. And for this is the manual default constructor. So for example, for ACE jump move, ACE jump, I think. Control C space. Yeah, so you can just choose a character. So for example, say I want source, and yeah, so you just need to get used to it because it's a very quick way to jump around. Keep moving with the cursor, takes a long time. Okay, so we can't have that if C++ standard is on. So let's just put these comments here. In C++ not yet, we're still always because we don't have defaulted functions. C++ 98 does not support move constructors. So not standard and requires manual move constructors. Okay. Now then, walk, the name tree is clearly missing an argument. We are characters here as well. Sadly, just have to now figure out. Okay, so I would probably now say auto probably const tsp, still too big, sadly. No, actually it fits. Okay, so similarly I think that will be rather identical. Make it slightly more readable. Okay. So now then, this has the advantage that we are now computing everything as it should be, which means that the template itself, so the reason why we went through all this pain is because the template itself now contains all the information it needs to obtain the state here. So we were going to do this in 2 steps. Step number 1 is going to be with casting. It's going to be very ugly, but we'll just do it. And interestingly enough, at the moment these are for any type of element. Presumably this will just default to whatever appropriate state. Did we do this with the move operator as well? Memory is failing me now. Oh, there we go. Check to see if we missed any. Right, okay. So, where are we then? Approaching, our time is actually fast. Okay, so the slight problem that we're going to have now is as follows. We need to go straight to the element to obtain the value for this thing. But of course, we probably have many uses of this call to the assistant. Let's see what RG says. I bet you we're going to find many templates. Okay. I take back what I just said. So at the moment, what do we have here? Aspect properties, expect expander, feature template bundle. Okay, that's the feature itself. Abstract bundle. Not really sure what these 2 guys are, but we can ignore that for now. Assistants and the aspect properties. So these are the actual templates you see here. And we see we have, well, 1, 2, 3, 4, 5. So it's quite a few. I mean, part of me is thinking, interestingly enough, notice that we have that in the feature bundle as well. Fantastic. So now that is a bit worrying. We missed something because we were so focused on primitives. How exactly does the feature bundle do that, I wonder? Somebody must be populating that. Let's have a look at feature. So technical space property, that's us. Feature template bundle, feature bundle, that's us. this is not very clear to me. It seems as if we implemented this in the features themselves, but we don't seem to be populating those fields. So very quickly, let's just have a quick check. Let's just go to a feature. Must have a variability here somewhere. Right, as you can see here, requires manual default constructor is a property of a feature inherited from this base class. You just have to very carefully make sure that that property is being populated, because it doesn't seem like it. There should be a transform somewhere. So if I look for transform.cpp, that's ours. These are the text model. As you see, it's definitely being used, because you see here in the text transform that we're trying to use it. These are all text model to text transforms. But what I don't see, which is very worrying, is bingo, there we are. No, technical space properties transform, that's us. So it seems very strangely that we are not actually populating that field, but we are using it, so it's always defaulting to false. So it seems that we got even more problems now. Not entirely sure why. So it's probably defaulting to false. So the problem here then is going to be that if the feature bundle contains a type which is marked as requiring a default constructor, such as, say, for example, an int, somebody should have gone to the feature bundle and then said, oh, by the way, you need it. No one's doing that at the moment, which means that we should really be creating lots of uninitialized code. So okay, let's just try as an example to see this problem. Let's just say we just created a whole lot of features, didn't we? Some of them with bool. So if I take something like the technical space properties feature, right, this guy here, presumably we will see, this is quite recursive, I guess, but you just have to close your eyes for a second and bear with me. What we'll see here is that there will be no default constructor and there is a default constructor. There is a default constructor here. So that is being initialized correctly. Presumably also we would have picked that up via our lovely Valgrind, doing too much work with Vagrant at work. So if everything is as expected, and all the builds look good, so this is good, this is the lunchtime, the previous commit builds. So Valgrind is telling us that there is no defect, so we think that everything is being initialized, this should be that needs to be initialized. And that also means that the code being generated here looks correct. Now what I don't understand is how, because I don't see any evidence of the feature bundle requires the default constructor being initialized correctly. There has to be a transform somewhere that does what we're doing. Now the thing we can do is we can look at that aspect expander and look for feature bundle. Something to do with features. Feature selector, we're using features. See, we're not actually touching any features here. Besides, we know for sure we're only looking for primitives in attributes, so it's not coming from here, this. So let's look very carefully at how all that is being populated. Seem to be doing the right thing, but we don't know why. And indeed, there is no evidence that we are populating that field. Okay, what we can do is, let's just do abstract bundle. I'll go up to abstract bundle, and if I say, please tell me of anyone calling this guy. So there are 3 references to this. Ah, so the oh, interestingly enough, the resolver seems to be very interesting. The resolver seems to be populating. Now I don't know why I can see that. Oh, we could see it. We just get blind. So okay, right. So we're doing it elsewhere. Right, you see here. If we have a simple type, when we do the resolution, I mean, this is not a brilliant place to do this, and this is why we couldn't find it, because absolutely random place. We're doing name resolution, and then suddenly we're populating something completely unrelated. But there we go. Fine. Doesn't matter. Practicalities of software engineering, I guess. Let's worry about that later. Where are we now? So the problem we have, the real problem, rather than the made-up problem that we just created a second ago, is in the assistant we either cast to one of the 2 types in order to get access to these properties, which we probably could do for now, or we change every single template to call the element directly instead of the assistant. I think we'll just go with the first. Let's just go for a cast. The reason why I'm going to go for a cast, you may joke, but you may laugh, but I'm going to go for a cast because the assistant will be decommissioned at some point. When we do that, we'll have to do the right thing. So we try to confuse just one issue at a time, because otherwise we're just never going to end. So what we'll do is we'll just do we'll do exactly this logic here, but in the assistant. Now this is not very nice. It's extremely horrendously expensive, but that's what we're going to do. Right, so we have 3 properties we need to look for. Clearly this is taking much longer than if we were not recording, but no point of complaining, I guess. So it requires manual default constructor. First one. So what we're going to do in this guy is we're going to say something like this. We must have an element of some kind. Here we are. So if we do something like ampersand get, so by reference of the elements. Now that's const, so we should probably there we are. So that looks good. And then well, good. Probably not the right word here, but and then if we then say this guy or that guy, oh, I guess we're trying to do here something like this. So if this guy or that guy, and then all we need to do is to say, okay, this is pointing, so technical space properties. Right, so we could well, let's just return that. I think that's good enough, isn't it? Really, very, very simple. Otherwise, return false. You see this rather nasty contraption here is casting the element to the thing we need. Then it's obtaining the value of the property, and then it's throwing it away, and then it's returning it. And then, so what we're doing now is just for now, we're just doing all this crazy stuff, because in the future, what we're going to do is we're going to update all. Well, we're going to remove the assistant. We're going to update all the templates to do the right thing. So we don't need to pay that cost just yet. So let's just get on with it. Manual move constructor. Similarly, and all we need to do is to update this to points. As you can imagine, this is very, very temporary. This would be a really bad thing to have in a real code base. But at least the code has improved slightly, ever so slightly. We are now... Oops, we are going too far. Oh no, that's correct. C manipulated, yes, that's fine. Righty, so stream manipulators. Okay, so if we've done our job, this should now result on green tests. Otherwise we'll have some very strange code generation differences. Okay, we have very strange code generation differences. So we lost some default constructors. Yeah, we just lost some default constructors. Now let's try to understand why. The first thing is probably to just look at the logic here. What did we say a second ago? I don't really know why Emacs insists on putting this miles away. So as you can see here, before we required a manual default constructor if the standard was C++ 98, or if for whatever reason we already required a default constructor. Now, that logic should have been moved across to here. So the first thing is, let's make absolutely sure that we are capturing correctly the standard. Obtaining that from the model. The technical space version has been populated because we do that very early on the technical space transform, as we've seen a few videos ago. So that should be alright. By now we are close to the end of the logical pipeline, so that's definitely populated. So then we're saying, we have to be careful here. if we were to... No, actually that's probably fine, because if you think about it, this is just a walking, right? So what we've done is, as long as we obtain the properties for every single model, that should be fine. And I think we don't do any ifs and buts, we just loop through every single element on our elements traversal. If there are properties, we slot those properties in, and we dump the streaming properties over to the log file. So let's just validate that we are not lying here. Let's use our usual tests, and let's just see what we think the streaming properties are. Well, to be fair, I'm actually going to say let's log on the test that's failing, really. And it's a C++98. Well, this already sounds quite ominous, doesn't it? C++98. Clearly we're not detecting the C++98 correctly, I think. Actually, I think I've lied, actually. The technical space transform. Let's just remind ourselves. The technical space transform. Well, we implemented that quite recently. There we go. That's the thing we're looking for. So let's just get some debug of the test. Sadly, this file always causes LSP to grind to a halt. Now, what was I saying? I'm not too sure. I trust the technical space transform. Right, you can clearly see we have a technical space version here. Now we know for sure the technical space version must be getting populated, because otherwise we would have seen errors in... Well, we would have seen errors like the C++98 model would have been incorrect, so they must be populated correctly. Otherwise, by now, many things would have been broken. So that's bound to be correct. However, and we know for sure as well that this is being called well before. One thing we did not check was... but that's weird, isn't it? So the C++98, so the technical space version is populated before we merge. Somehow we must be propagating it from the merge. Well, let's just run this test again. And then have a look at this transform, I think. Rather confused at present. So around here somewhere there shall be a 98 log. We can grab that log for the particular logger we're interested in. We can log view it. Right, so this is going to be doing whatever it is that it does, and in the end we see the streaming properties as we will use for whatever container that is. So you can see here that some kind of reading is taking place. So that looks good. We seem to be reading the properties correctly. That's good. What we need to know is whether we are in C++98 mode. So without further ado, let's say technical space version and then TSV. Now I suspect this is going to moan, so let's just go here and say identity probably. Notification, IO, entities, technical space, version, I suspect. Right, so now this will tell us what we think the version is. We think is 98. Good. We think is 98, so that's good. And then what? Well, this is where I think we just have to be very careful that the logic is not broken, and I reckon it is broken. The reason why I say that is because what happens if, so if we look at these diffs, is there something special about these types that are failing? For example, class no properties. Right, so if you have no properties, wow, okay, funnily enough, that is actually a fix. These are actually not bugs, but fixes. A class with no properties should not require a default constructor. And a class called no default constructor should surely not require a default constructor either. I am slightly surprised that we had these errors, but I mean, of course, I'm not saying the code that we generate is perfect, so clearly there will be bugs. But so let's look at our C++ 98 model then. We are quite running out of time, 2 hours and 18 minutes. This is becoming quite a long one, but it's quite reflective of the type of things that happen around here. Right, so this is the case where, for the first time in a long time, we have found a problem with the generated code rather than a bug on the refactoring. So there we are, a class without any properties and a class without a default constructor. Both of these should not really require a default constructor, and that's correct. Somehow we were not generating these classes correctly. Hard to believe, but it's true. So we'll just get the latest code generator, I guess. And then we will jump over to another area, like say for example area 13. And we will go to this guy here. And perhaps we can call this the C++ ref info code. And what we need to do here is we need to, haven't done this in a while, as you can see, generate, perhaps the premax would help. Now I think we need another area here as well, so let's go for area 14 and let's call this git. And what we'll do here is we'll see the extent of our changes, and it doesn't look too bad if I'm honest. So I'm just gonna obtain the usual setup. It's not what I meant to do. And there we are. Right, so what happens then if I attempt to compile this guy and okay, so because we haven't compiled this model in a little while, it's building every single thing. Okay, not to worry. I think we can't run our test just yet after this because we're probably pointing to the wrong model. Master. And sadly we can't really run two compilations at the same time, I don't think. In fact, I wonder if you can. What happens if I go to 5, rename buffer, let's call these C++ info compilation. Okay. Now let's run another compilation. But this time let's point to integration. Aha! It actually seems like we can run multiple compilations. That's quite good. Now, unfortunately, the first compilation has failed, so but the second compilation probably will pass. Very nice. Okay, let's look at the compilation that failed. Compilation. Now, I don't know why this is failing, if I'm honest. I thought that if we... maybe it's because we created an explicit constructor somewhere. Well, let's think about this then. What's happening is we are not getting this default constructor. In fact, to be honest, I bet you this is the only error we're going to get. We're not getting a default constructor. And the type, the compiler is not giving us a default constructor either. So the problem now is that the compiler is now saying, well, you probably created some other constructor. Let's have a look at what this guy says. No, sorry, this is the generator. So this guy here is probably going to say, well, you've got a constructor that takes an argument, so why would I bother creating you a default constructor? Which is good and correct. But then, now we found yet another problem. And that problem is that, quite sadly, the test data generated can't cope with types that don't have a default constructor. So we can't actually create this type. This is a bit of a problem. What is the quickest way to fix this? It's not obvious to me why we were generating default constructors previously as well, so we could actually quickly hack this. We would have thought, one would have thought this would... Oh, actually, do you know why? I bet you that in C++98, yeah, this is what's happening, isn't it? If you say C++98, then it will, if we go back to our assistants, in fact not quite the assistant, but the diff we had with the assistants, yeah, I can see exactly what's going on here. So basically we said if in C++98 we must always create a default constructor because we cannot make use of default. See, this is actually not true. In C++98 we can use default constructors as long as there are no no other constructors. So we need to put the bug back actually, just so we can go past this hump, because this is going to require a lot of hackery to fix this properly. So what we should do is we should say or, which is what we should have said in the beginning anyway. And I bet you, similarly, no, I think that's fine. Right, so, okay, let's just do two things then. Let's go back to here, and let's say, in fact, this is probably enough. And let's create a story for this. Default constructor correctly generated in C++98. And we have this logic in logical. What are these? What are these? Well, what that is. First, before we go anywhere, let's just say begin source and source. This is actually becoming quite a complicated task. So we have this logic in whatever that is. Technical space properties transform. This is actually incorrect. We can use default constructors in C++98 as long as there are no other constructors. The problem is we are relying on the default constructor in test data generator. So if we fix this with an AND, instead of an OR, we break that code. We need to figure out what the correct implementation is. Right, okay, so this will give us enough to get going. We will bump into this issue sooner or later. For now, we will reinstate the bug. What thing we do not do here? No, this is actually the same session, so that's correct, sorry. We are very close to the end of the sprint now, I think. Yeah. And we are also quite close. Oh, what time is actually is? Okay. Right, now what's going to happen here is the following. I'm going to go back to where I was, and I shall remove all these guys here. I should probably git ignore cache. Okay, so now then, what was going to happen is we're going to return back to our compilation, and annoyingly, we will now, I think, do the right thing. Or in other words, we're going to reinstate the bug. And interesting enough, that did not solve the problem. Okay, I think no properties is probably okay. Well, okay, we need to understand why this adding an OR here doesn't solve the problem, because it should have fixed the problem. So if it's a alternative, or if it requires manual default constructor, then set it to true. This should have fixed the problem, I should think. Let me set this anywhere else, perhaps. What's this? So if top level, so yeah, basically if you're top level and one of the guys is a simple type. Well, actually, do you know what? Let me just put another story here saying I really don't like the fact that move default constructor work from resolver. And we should say something like at present we are populating the default constructor for the bundle in the resolver. I wanted to write the story for this and then I forgot. I should really have like a shortcut here for source. Begin src C++ and src. This is very confusing because one would assume the resolver just resolves. We need to move this logic to whatever that was. Technical space properties. Right, okay, fine. Now then, we still don't know why we're failing. A bit worryingly. I wanted to finish this in the video rather than stop and start and do this outside of the video, but we'll just give it a good go for another 10 minutes, and if you can't, I might just require more concentration. So if we are C++ standard 98, then we require a manual default constructor. Now that logic now seems to be in line with this guy here. Requires manual default constructor if you are C++ 98, or if we require manual default constructor, then we require manual default constructor. Oh yes, we were just making sure that there is no other place where this field is populated. So okay, it's fine. We set it at the top level, and we never overwrite it. Ah, bingo. So the problem here is this. We need to do this twice. So if we are C++ 798 or we are top level, then we require C++ 98. The reason being that I think top level classes, I think we're just not getting to this bit, hopefully. I think the other problem we're going to have is, this might fix one of the problems, but I think we'll have, yes, as expected, we'll have at least one more problem, which is if we have no properties. Right, so once more, we need to have a specific hack for this. I mean, we have two hacks here already. We'll put one more, and the hack we now need is the following. If you have no properties, and you C++ 98, then we need to set this guy up. So, sort of never-ending this hackery, I think. So we should say something like I mean, we're not even going to call compute, I don't think. Oh yeah, so we have R here. So okay, so if attributes dot empty and we are in C++ 98, just make sure we, oh, not quite that guy, more this guy, make sure we set this to true. programming. What do we do here? See, the reason why I don't really like structured programming all the time is, look, I just now this doesn't fit anymore on my screen. So I actually gonna go for an early return here. I apologize to Mr. Henny, but I just can't cope having to break up lines because I've lost my columns. Right, now then, what are we saying then? We are saying, probably a fat big warning here. Note, if a class has no properties and we are in C++ 98 mode, we must create the default constructor. Actually, believe it or not, this probably would have been okay, because I think that here the compiler, actually, to be honest, I'm not going to put this hack in yet. Let me just try. Before I put this hack in, let me just try to regenerate the code in. Actually, I can't really do that. But if I just get the latest code generator, what is going to happen, if I am right, is that the code generator will not generate the default constructor as we want to, which is a fix. What am I doing? I forgot to remove that code, didn't I? Right, so let's generate a new code generator without this fix. Then let's regenerate the code. So I think that the bug that we experienced a second ago won't manifest itself if you got no properties. Well, that's my theory anyway. The reason why is because we will get the compiler to generate the default constructor, presumably. There is no other constructor. We have no properties, so therefore there will be no other constructor. So I think that's a good fix, actually. No property should have no default constructor. What we can't do is this guy here. We can't do that guy because that's definitely going to break the wall. But this should be okay. So if all goes according to plan, I think it will be okay. So in preemption, I'm going to remove this hackery. One hack less. Oh, and again, let's go for our lovely rename the buffer. Actually, I wonder if, let's say I don't rename the buffer. So I revert back to that name. If I do a control, let's go back to here. If I do a control U, control C, C. It's not actually running. Okay. Control U, control CPC. There are no tests. Ah, bummer. It actually killed the previous compilation and restarted it. You have to actually rename the buffer. Oh well. So let's just run the test anyway. Hopefully this will get green. It is green. Excellent. So we will just continue doing whatever this thing is doing. Now then, this is very good. We are now green. So let's get rid of that. And we are quite close to the end of this. We have literally 10 minutes. Okay, so that's green. Excellent. So what we're going to do now is we're just going to say, so these are fixes. So what was the last commit that we did? Handle C++ 98 in technical space properties transform. Good. And then text.cpp use new technical space specific space properties in assistant. Right, okay, that's very good. Okay then, so we need to commit before we do anything else. Let's commit this. Clearly we meant to stage, where are we? C++ 98. Do not generate default constructor if there are no properties, which is a good thing. We didn't run all tests, to be fair. And if that is green, which I hope it is, we can merge to master, push to all of our remotes. Okay, that guy is happy now. And whilst that's going on, we will now start the cleanup. Hopefully we can do that in 10 minutes. So we have aspect properties here. We have an aspect expander. See what that does. I'll probably go as far. Oh, I've got too many compilations going on here. Convert dogen.text.cpp.dia to JSON. Indent. Right, so we need to generate everything. Right, so now let's have a look at the breakage. Hopefully this will be more or less constrained to the model expander. If it isn't, we might just have to end the video here. Reason being that I need to finish in 10 minutes, so we're not going to have enough time to fix anything more complicated than that. See, we are down to almost the end, I think. Help us. Of course, you remember that we still haven't done the C# version of the aspect properties, but let's not worry about that just yet. Nothing like a cold coffee. When I was a junior developer, I used to work in a server room. It was always at a very nice, cozy 5 degrees or so, 10 degrees. So I never really, for a year or two, I didn't have any warm coffee. So I got used to drinking cold coffee. Or coffee in all stages of temperature. All variations of temperature, I guess. Okay, so I should really be showing you what the compiler is doing. Okay, so that was easy enough. We got rid of all of the properties in one go. So whilst that's doing whatever it's doing, we can now say text.cpp remove aspects properties and related classes. And that is it. We've done the aspect properties. It took a lot longer than we expected, thanks to a very large number of problems. C++ and C#. So now we know that only C# to go. And with this, I think we concluded the oh no, we haven't quite yet. We haven't quite reached our target of 80 hours. So, how much time have we got? 24, we have 5 minutes. I think we can, let's just keep going for another 5 minutes. What we'll do is not going to finish this, but let's just do something quick. Let's do another 10 minutes just so we can do 80 hours. I suspect there will be some features around here. Now, annoyingly, interestingly, we don't seem to have Ah, yeah, one is here, the other one isn't. So I'm not sure. Well, actually, to be honest, let's not worry about that just yet. What we'll do is, for this present exercise, we will merely add the two missing guys. That I think should be enough. So this should get us another few minutes on our clock. Just about fits. Probably should move up a little bit. Oh, we don't seem to have snap to grid. Right, so this will give us the two properties we need for C#. Now, we need to understand how exactly this property is being populated. The other problem, of course, is that well, actually, to be fair, I will take the liberty to well, of course, the annoying thing about this is these distant properties, these aspect properties are coming into the C# namespace. And of course, we did a hack, didn't we? We, instead of actually renaming this properly, we left it as C#, C++, which means that these guys now are coming in under CPP aspect. We now need the C# aspect. Annoyingly, we could continue the hackery, or we could rename these features and put them in the right place. Right, I'm not too sure. Let's just continue clocking at any rate. Let's just put some notes here. Features are still located in TS specific namespaces. We need to move them. Well, but do we need to move them really? Because I mean, it is a C++ specific thing, so not sure if we want to move them. What annoys me, of course, is that if I now start to create C#, well, actually, there is an easy way to fix this. Not very nice, but hey ho. So let's say the prefix is MASD, and then let's say that these guys are going to go under this guy here. I think this will give us what we're looking for. Sadly, hopefully there will be no differences because we've already made some changes to the code generator. Let's make sure we're running from the latest code generator. Now I expect only the new properties to come through, nothing else. And that is correct. Good. So that being the case, I am now going to pump the new features into here. Now I have no idea how this floating point is being generated, so hey ho. Let's ignore that for now. Excuse me. One of the downsides of leaving the window open. Sneezes. So then, if we let's just boolean and set to true. Right. So then, let's generate again, and then after we generate it, let's convert. Now we have to convert the logical model. Right, I think this should us there. In terms of time, so this will add the C# features that we need for the aspect properties. We still have a few things here that need looking at, to be fair. But we will probably have to just do the final mop-up would have to be on a per model basis. We tried to do C# and C++ and the related properties, and it kind of worked so far, but I think C# is going to require a bit of attention at the end. Right, I think that's just going to compile, so I'll just say something like logical add C# properties to technical space properties. I'll call this attributes just so know we're talking about something different. And okay, that did not work so well. Okay, my bad. I forgot to remove this guy here. So let's generate everything again. Clearly we can't commit that because it's not passing all the tests. Let's convert text sharp. Let's indent it. Let's try again to run all the tests. Move feature to logical model. Right, so that's all good. Okay, let's see how far we are from our 80-hour target. Still a couple of minutes, I think, quite annoying. Okay. So then, what have we got to do still? I think, well, anyway, we'll just do the concluding remarks for this video. So what have we done then? We have managed to, with some pain, move the aspect properties from the formatable element properties. These have now found their new home in the logical model. Still slightly hacked, but not too bad really. We have technical space specific properties here. This needs a little bit of tidying up so that well, first we map them to technical spaces, I guess. Or perhaps we'll stay like this, I don't know. It's we have so much to refactor that sometimes we just have to get on with it. And I think that was it really. We now need to move over to the helpers, I think. It's been a bit of a long road, but hard to believe. We are quite close to the end now. We just need the helpers, and I think for the helpers, I may be talking nonsense here, but what we well, of course, when I say that, I'm not forgetting that we still need to do the aspect properties of C#. This might not be trivial, but I wonder if we should just, in fact, to be honest, what I'm going to do is I am actually going to close this story because I think we should, now we got the 2 minutes that we needed. I actually think we should separate C# from C++ here, I think. Let's just deal with C# C++ first, and then let's just say move helper related classes, and we should be clocking this as black cloud work. Move helper related classes to logical model, and move C++ C++, operator class, come on. So here we probably will just we'll just as usual add the names of the classes as we go along. This helps in the release notes. Sometimes we need to remember what we did. Something like this, right? And as we go along, we'll just keep adding these. Yeah, so I think we're actually getting quite close to the end of this, right? And then once we've done the helpers, which I'm hoping is not going to be awfully complicated, we will end up with a C++ model that contains just the model text transforms, which is what we've been trying since the beginning. Now, unfortunately, we haven't quite got to paradise just yet because we still have all this loads of nonsense here, and we won't be able to touch any of that for now. But we will soon be able to take all of the contents here and move to our logical physical space model. And similarly, with C# will be something similar. We won't finish the Refactables formatter this sprint. Of course, the sprint's almost over. But we probably will finish it early next sprint, ideally. So it's been a pretty good sprint, I guess. Okay, I think that's all for this video. Oh, while I'm here, let me just complete. Okay, we reached 80 hours. And we can now just complete our work here. I think we just need to push all this stuff to all of our remotes. And that's it. Thanks for watching. That's it for this video at any rate.